Let's start on lesson 1.3. First thing you need to know for this lesson, there's a lot of vocabulary. There's a lot of words on this page and the next one. So I'm just going to highlight the stuff that's really important that you need to know. So first one, x-intercept, where the graph touches the x-axis, always written as an ordered pair, number, comma, 0. Always, always. Y-intercept, where the graph touches the y-axis, and it's written as an ordered pair, 0, comma, a number, every time. We have relative maximums. That's where the y value is greater than all the y values near it. Key to that one is it's a y value. Maximums and minimums are not written as coordinate points. They're written as y values. And then the relative minimum, when the y value is less than all the y values near it. So, typical maximum would be that. Typical minimum would be that. We have already talked a lot about open and closed intervals with domain and range, so we're not going to worry about those ones too much. Increasing is when the graph is going up from left to right. So you're going to read the graph like a book from left to right and see if the graph is going up or decreasing if it's going down from left to right. Constant is if it's flat, but we won't worry about that one too much. Then a function is positive when the y coordinates are positive, and I'm going to have you write aka above the x-axis. Anything above the x-axis is positive. Negative when the y coordinates are always negative, aka below the x-axis. Last one is end behavior. You have two types of end behavior. You have right end behavior and left end behavior. They are always written with these statements. The only thing that changes is that C turns into the number for what your end behavior is. And I'll show you more of what that means in a second when we do an example. Last pieces of symmetry. We have symmetric to the y-axis. So it's just symmetric across the y-axis. Looks the same. This is also called aka an even function. We also have symmetric with respect to the origin. This one's kind of funky for me to look at. So the way that I usually think about it is I pretend I put a pin right there in the origin. And then I imagine rotating one side of the graph over to the other. And if I put that pin in and that rotates on top of the other side, then it's symmetric to the origin. This is also known as odd functions. Last one, it can also have no symmetry. None of the above, and that's okay. So that is all our vocabulary for this chapter. We'll go over some examples and apply that vocabulary in the next video.